All right, so we've been talking about how to factor polynomials. So we already talked about how to factor in the perfect cube form, right? And that's used if I have two terms. So for instance, if I have a cubed plus b cubed, just as a reminder, we said that factored into a plus b, and then a squared minus ab plus b squared. If I had a cubed minus b cubed, it would be really the same thing, except now that negative sign is in the first parentheses. So a minus b, a squared plus ab plus b squared. But we know that not all polynomials only have two terms, and certainly not all of them are perfect cubes. So we need some other things that we can take a look at that might help us factor. One of these would be to factor in the quadratic form. That's used if I have three terms. So here's an example. I have three terms. The other thing that you'll notice is the exponent on the first term is an even exponent, and the exponent on the second term is half the exponent of the first term. So if that pattern is true, then you should see if you can factor it as if it were a quadratic. So think about it as if it was x squared minus 4x minus 12. How would you factor that one? Well, I would factor that one as x minus 6x plus 2. Well, let's go back to my original equation now with an x to the fourth. If I split my x to the fourth terms, I would have x squared and x squared. So it would factor exactly like the quadratic, except it would have a higher exponent. So it would factor as x squared minus 6, x squared plus 2. Let's take a look at another one. First thing you want to see is it has three terms. The first exponent is even, and the second one is half of the first. So we should at least try and see if it's factorable. Well, I can factor it into 3x squared plus 1, x squared minus 1. You can see if I multiply the outside terms, I'd get a negative 3. The inside terms, I'd get a positive 1, so that would give me to my negative 2 in my middle term. But don't forget that when you factor these, you have to factor it completely. X squared minus 1 is the difference of a perfect square. So that one you can keep factoring. So if you're factoring it completely, it would be 3x squared plus 1, x plus 1, and x minus 1. So always make sure that you look at your answer and ask yourself in each parenthesis, can I factor it further? Now here's another example. The first thing you always want to do whenever you are factoring is look at each term and find out if you can factor out a common factor. In this case, I could factor out a 2. Well, if I factored out a 2, I would get x to the fourth minus 81. Well, this looks very similar to the difference of a perfect square. We're normally used to seeing perfect squares as x squared, but any even exponent would be a perfect square. X to the fourth could break up into x squared and x squared. X to the sixth could break up into x to the third and x to the third, and so on and so forth. So I can continue factoring this and factor it into x squared plus 9 and x squared minus 9. But once again, x squared minus 9 is the difference of a perfect square, so I can keep factoring it. X squared plus 9 is the sum of a perfect square, but I cannot factor that one any further. So my final answer would be 2, x squared plus 9, x plus 3, x minus 3. Make sure in the very beginning you don't simply divide out the 2 because it's not an equation. So you can't actually divide it out, but you can factor it out. Another way that we can factor polynomials is by grouping, and this would be used if I had 4 or more terms, but generally 4 terms. And we call this the 2 by 2 method because what you do is you look at the first two terms in your expression, and you ask yourself, what can I factor out of the first two terms? Well, and then you look at the second two terms and ask yourself, what can I factor out of those two terms? Well, in the first two terms, I can factor out an x squared. If I do that, I'm left with an x plus 2. In the next two terms, I can factor out a 3, and if I do that, I'm left with an x plus 2. In order for grouping to work, the two expressions in the parentheses must be exactly the same. If they are not exactly the same, then grouping wouldn't work, and you'd have to try some other method. But what this tells you is the stuff that you factored out, the x squared plus 3, is your first term, and the stuff in the parentheses is your second term, listed only once. So this would be x plus 2 times x squared plus 3. And remember, if you were ever unsure, you could always multiply it back again and see if you got back to your original polynomial. So again, that's an x squared, so you want to watch to see if you can factor it again. But of course, x squared plus 3 is as factored as it gets. So why don't you put the video on pause and see if you can go ahead and factor this one yourself. All right, so in the first one, I can take out an x squared minus 3. In the second one, I can take out a 4. That leaves me x minus 3 in both parentheses, so in fact, grouping will work. So my factors are x minus 3, x squared minus 4. I have to look at both parentheses, see if I can factor further. X squared minus 4 is the difference of a perfect square. So I can factor that as x minus 3, x plus 2, and x minus 2. Let's take a look at this one. In the first one, I can take out an x squared. I get x minus 5. But in the second one, I really can't take anything out but a 1. But you always have to take something out, even if it's just a 1. So I'll put a 1 in front of it, x minus 5. So I have x minus 5 in both parentheses. Grouping works. So my first factor is x plus 2, and my second factor is x minus 5. All right. Take out the x squared. You can only take out here now in this one. If this is a subtraction sign, you should take out a negative 1. But if you do that, watch the parentheses, because then a negative times a negative would be a positive. And then that gives you x minus 6, x squared minus 1. But again, you can continue factoring. So take a look at this one. What do you think you should do first? Right. You should factor out a 2. Again, remember, you cannot divide it out because it's not an equation, but you can factor it out. Now that you've factored it out, you can continue with grouping. Right? So you can take out an x squared in the first one. You can take out a 4 in the second one. And that'll give you 2 times x plus 3, x squared minus 4. Take a look to see if you can factor further, which you can. And then that will be your final answer. All right, put the video on pause and see if you can do this one. Did you get the right answer? All right, so here you're going to take out a 6x because now they not only share a number, but they also all share a variable. So when I do that, I can now continue with grouping in what's left in the parentheses. I can take out an x squared. I'm left with x plus 2. I can take out a 2. I'm left with x plus 2. So now I have 3 factors, 6x, x plus 2, and x squared plus 2. Again, I should look at the x squared plus 2 to see if I can factor it further, but I cannot. So this would be my final answer.